Today, we will make our way through 2G. We're doing derivatives of logs. So we've done exponentials, we've done product rule, we've done quotient rule. Today we're going to learn logs and then we're going to combine everything we've learned together. So we have, if y equals ln of x, then dy on dx is 1 on x. And if y equals ln of f of x, that's if we have some function in here, any function, then dy on dx is f dash of x on top of f of x. Okay, so first one here, we've got y equals 3x times ln x. It's times. What rule do I have to use? The product rule. Very good. We use the product rule when we're multiplying two functions together. So we'll have u is 3x and v is ln of x. That makes u dash 3 and v dash, well, we're told up here, ln x goes to 1 on x. Okay, so dy on dx is going to be u dash v plus u v dash. Just talk about how these things can be simplified. 3x times 1 on x, we can simplify that part. We could write it as 3x on top of x. Alright, it's a number times a fraction. We have x at the top, x at the bottom, so we can cancel. And the other one is if we have 3 ln x, just an alternative way to write it is ln x to the power of 3, isn't it? Ln x to the power of 3 plus 3. Okay, so lots of different ways that it could be presented. Be aware of the similarities there. Okay, we've got y equals ln of 3x squared take 2x. We have ln of a function. So we're going to use this rule. Alright, all it's going to become is a fraction. Okay, and you just take what's inside the brackets and put that at the bottom. That's the denominator. It's going to be 3x squared take 2x. Okay, that's f of x at the bottom. And then at the top you just have the derivative of what's inside the bracket. You just differentiate this part here. That's going to be 6x take 2. Alright. Okay. We'll move on to C up here. We can see we have e to the 3x take 2 times ln of the square root of x take 5. So what we can do, we should recognise we've got times, so that means we use the product rule. So we've got u is e to the 3x take 2, and v is ln of x take 5 to the power of half. Now in order to make our differentiation a bit more simple, I'm just going to bring this half to the front. So another way we can write v is half times ln of x take 5. Okay, that number can just come out the front. And that's much easier to differentiate. Now we don't need to use the chain rule in there. Okay? So that's just how I'm going to express v. So I've got u. Okay, here's u dash. We need to use derivatives of exponentials. If we have e to the f of x, then the derivative is f dash of x, e to the f of x. So we differentiate this. That's going to be 3. And then we have the same thing remains. 3 e to the 3x take 2. Alright, so the derivative of that is 3, and then that remains. Okay, we'll go for v dash. Okay, in order to find v dash, this half, that's just going to hang out there. Half's just going to sit there. And then I've got ln of x take 5. ln of x take 5. That's ln of some function, x take 5. Now if I've said when we have the function, the denominator is just whatever the function is. And then at the top, we have the derivative of x take 5. When we differentiate x take 5, x goes to 1 and the 5 disappears. Okay? So that's what our v dash is. That's a lot simpler than having to use the chain rule, like we would have done if we kept the half. Okay, we've got all of the things we need to bring it together in the product rule. So let's make the statement. dy on dx is u dash v. Plus, and I'm I'm just going to write underneath, the plus underneath, just so I can save that space, plus uv dash. All right. Okay, and of course we can expand and simplify and so forth, but we'll leave it for now. Okay. Here we have the cubed root of ln of x to the 5 take 2x. So here we absolutely have to use the chain rule. Let me remind you, what we have here is we have ln of some function to the power of n. Alright? And that is not the same as ln of some function to the power of n, where the n belongs to the function. Here the n belongs to ln. Okay, it belongs to the whole thing. Whereas here it only belongs to the f of x. This is the circumstance where we can move the power out the front. This is not. Now we know that's the case because we have the whole thing in the cubed root, rather than the cubed root just applying to this term. Okay? Notice over here how the square root just applies to the x take 5. That's why we put the half there. Right? It doesn't apply to the whole thing. You've got to be aware of those sorts of things. So, I'm going to express it first like this. I'm just going to rewrite it differently. It is ln of x to the 5 take 2x to the power of n. Okay? That's some function to the power of n. Alright, and so now we're ready to use the chain rule. For f dash of x, we're going to go n f of x n f of x to the n take 1. N f of x to the n take 1. And then we multiply that by f dash of x. So now we're just looking at ln x to the 5 take 2x. Ln x to the 5 take 2x. And so we've said whenever we differentiate ln of f of x, the denominator remains as x. The denominator remains as whatever's inside the brackets, and the numerator becomes the derivative of this. 5x to the 4 take 2. Okay. We've got one more, don't we? It's f of x. And we're told to show that f dash of x is 2x plus 6 on x squared plus 2x. Okay, there are two procedures here. Two procedures we can use. First, alright, and I think the most simple procedure, actually I might explain the complex procedure first and then we'll just do the simple one. The complex way to think about this is to go, that's f of x, okay, that part there, it's some function. And in order to find f dash of x, we would need to use the quotient rule because we have u on top of v. Alright, so if we were going to differentiate this, we're going to have, at the bottom, we'll just take the same function and put it at the bottom, x to the 3 on x plus 2. Alright, that's f of x, isn't it? Look here, we have ln of f of x, the denominator is f of x, that's what I've put there. And then up here, we're going to need to perform the quotient rule to establish what this is. Okay, do that and then go AD on BC, expand, collect like term, simplify. Okay. Can be done that right way, you will get the right solution, but it is the longer way of doing it. So the best way to think about this then is when we have ln of A on B, we can write it as ln of A take ln of B. So we can split this into two terms. We can make it ln of x to the 3 take ln of x plus 2. And that is so easy to differentiate. And like you can even bring that 3 out front. So it's 3 lots of ln x take ln of x plus 2. Look how lovely and beautiful that is. So that's f of x. Okay, it needs to be very clear. This is the function, and that's why we've written equals equals. And then when we differentiate, we need to state very clearly this is now the derivative set. So we're going to have 3 times 1 on x, take, and here the derivative of at the bottom we're going to have x plus 2, and at the top we're just going to have 1. Okay, and what we'll find is if we collect them, we should end up with the exact same thing we have up here. So let's go about that simplification. We're going to have 3 on x, take 1 on x plus 2. In order to perform this fraction operation, they need to have the same denominator, which means I need to cross multiply. So I'm going to multiply this term by x plus 2 on x plus 2. And I'm going to multiply this term by x on x. We're not changing their value, we're multiplying it by 1. Alright, so that's going to give us, we'll get 3x plus 6 here, and we'll get take away x, and all of that's on top of x times x plus 2. Okay, and you can see that gives us 2x plus 6 on top of x squared plus 2x, as required. QED. All right, so let's get into exercise 2G. Any questions?